iterable we have seen from lang package. In that iterator method we have seen has next, and remove, right? All three we have. Enumeration we have seen, right? In stack and vector we have seen. Then in these we have seen some hash map and linked hash map, right? So these again we are going to see. And importantly, we have seen the methods of collection interface, right? The methods of collection interface. Now we are going to see the list. But before that, in last class, we have seen two error messages we have seen in collection, right? Two error messages we have discussed in the collection. One collection will create, and on this collection set is the collection creating newly, one new collection created. And that if I say collection is empty currently, right? We have not stored any element in this. And if we say collection one dot get, not get, it is contains an object, say hi. But currently the collection is empty, right? And we are saying contains is an object, it is available or not. What it should give? It is not error, right? Not here. At which point we have seen.
So I think collection one dot element. Next element if you call.
Next element will be in iterator. There is one. One is with iterator, that is in next element directly without checking condition. One more, right? In next it is like this. Say if I create an iterator, IT, and IT is already there. 1, 2, collection one dot iterator. And in that, without checking the condition, if I say next, when it is empty, IT2 dot next, it is empty, then it is an error. And one more we have seen. This is no such element exception. This is one. And one more important, which we missed in the last class, that was I wanted to show today actually. So suppose you have this collection. This is a collection. And we'll create an iterator for this also. Maybe somewhere it is there. Or I'll just put this part in comment. This. And first it is just printing the collection, and collection is having this element, right? Collection is having this element. So this is the element printing for the collection. And now I'll create an iterator for this. Suppose iterator IT is equal to collection one dot iterator. This is iterator method for the iterator, right? And now in this, I have to give a condition while IT dot has next, then it has to give all the elements, right? So all the object I'll put in obj, and then ID dot next, right? And then you print it. So all the objects you are accessing from the collection one by one, right? One by one. And here with this next, we have seen the remove method also, right? How remove method is, if object equals to, say if it is JDBC. If it is equals to JDBC, then this object has to be removed, right? So what will you do? IT dot remove. IT dot remove. If it is equal to JDBC, then JDBC, this object, current object has to be removed. So this JDBC will be removed, this will be removed, and this will be removed. This also is going to be removed. And after that, again, when I'll print the collection, that JDBC should not present. Right? That JDBC should not present. Run it. Here, all JDBC removed. Right? But you notice here how it is currently how the collection is, you have a collection which is collection 1 and it has a object. This is the collection object. Here we have stored one hi, one JDBC, one hello, 99, again JDBC, something like this, right? Some other collection objects are also there. And then when you will print, when you are printing it, it is printing the entire collection. Okay, fine. When you are creating an iterator, this is the iterator, and it is pointing to the same collection before to the first element, right? Before to the first element. Then when you will say has next element is present or not? Yes, it is present. If it is present, move the cursor to the next element and remove it. Means this cursor has to move to this element and this element has to be returned, not removed. Hi should be returned and that is stored into obj. Means now obj is a reference variable which is pointing to hi. Right? It is separate. Obj is printing. Fine. Now, if obj equals to JDBC, this obj is pointing to an object. If object content is equals to JDBC, then remove, and it is equal to not JDBC. It is high currently. It is not equal. So these two part is not executing currently. At this iteration, it is not working. So this is just printed obj, which is high, and the iteration is over. Then goes for the next iteration. In next iteration has next. Okay, it has next. Currently, this cursor is pointing here. Has next, yes, JDBC is there. Next is JDBC. Then again, when you will say it.next, this cursor has to move to JDBC and JDBC has to return that is stored into obj. Means currently now obj is pointing to JDBC and not in hi. Right? Then printing obj. Obj is JDBC and JDBC will be printing. Then again, if obj content equals to JDBC, obj contents equals to JDBC, it is JDBC. If it is equals, then remove. But where you are applying the remove method is applied on iterator, on this iterator. This is important point you have to remember. You are saying that if the current cursor is pointing to an object which content is JDBC, then where it is pointing currently, remove this. Right? But we have seen one more remove method in collection interface. In collection interface also we have seen one remove method. One remove method which is having some content. In collection interface you have seen remove method, but this remove method is having an argument object. Right? And this remove we are not applying on the collection. Here we are not saying remove. It is not this one. It is in this we are applying remove. Means where the cursor is currently pointing from this iterator, this object has to be removed. And when it is, if it is this, if this condition is true, then currently pointing object by the cursor has to be removed. And that method you have applied on the iterator. You notice this. But last class, what remove method we have seen, that remove method we have applied on collection. We have said collection.remove with some object, right? With some object. So this is removed and it will work fine. It is working and it is giving all the outputs, right? Now, once again you see the output. Run it and check. It is working fine. Removing all the JDBC. And remaining elements are present fine. Now, one small change if we do apply the remove which is from the collection. Okay. If I apply the remove method which is from the collection interface, then how will you apply? Instead of writing if obj equals this, and if you remove, instead of writing it in this way, what we can do is this statement you just put in comment. If it equals to JDBC, then collection1 dot remove. JDBC. This is the difference. Now we are applying remove operation on collection object. Previously, the remove operation was applied on iterator object. Okay. Previously, the remove operation was applied on iterator object. Now it is in collection object, right? In collection object. Now what will happen? You check like this. It is an exception. What is an exception? What is the exception? Concurrent modification exception, which is very, very important. You will get interview question on this. Concurrent modification exception in collection when you will get. Normally concurrent modification, concurrency when you say, you will start thinking about multi-threading, but it is not that kind of thing. Here concurrent modification exception means, this concurrent modification exception is not about the concurrency. It is because, so now here what we are doing, this is one collection. Collection object is pointing to the collection object. It is fine. It is fine. And in this, what are the operations you can perform that we have seen in the last class? All those methods you have seen, and those methods, all the operation you can perform here. Remove, add all, contains all, like those operations, right? Or contains all this. Now, iterator is having three methods. Has next, and remove, right? These three methods are from iterator. So collection is pointing to that object, iterator is pointing to that same object. Both is pointing to the same object. Now at a time, you are performing has next, and this remove. These three operations if you perform at a time on this collection, it works fine, no problem. But if you add some function from these in this collection apply, at the same time, you are applying this function also in this collection. Then you get concurrent modification exception. Concurrent modification exception means in this collection, same collection, two reference variable is performing operation. Collection performing operation, iterator is also performing operation. Iterator is performing operation, collection is also performing operation. Then you are going to get a concurrent modification exception. But this only performs the operation, no concurrent modification exception, it will work fine, no problem. Like this remove we have seen here, it is working fine. But when I'm applying this remove, it is giving an exception. Right? This remove, it is giving an exception. Okay, this is fine. Now what I will do, it is not remove. Assume in collection I am not applying remove. In collection I am applying add. Collection one dot add. So it has to add something. 1, 2, 3. Right. So if the current object is JDBC, add 1, 2, 3. And after that, again I am printing the collection. Now you run it. Again concurrent modification exception. Concurrent modification because of add now. Add is from the collection interface. So add and remove giving collection concurrent modification exception. Add, remove is giving concurrent modification exception. Add is also giving concurrent modification exception. If I check, if it is equals to JDBC, then int, or I'll just write one statement here like this, that collection one dot size. Now run. No problem. It is working fine. Whenever JDBC will come, it will give size once, 10, size once, 10, size once, 10. In this case, this method is working fine. Add method of the collection is not working and remove method of the collection is not working in this iterator, but size function is working fine. Or if I check contains, suppose collection one dot contains of something, ABC, contains of ABC. This is also a method from collection, right? And now I have to give a braces here because two statement in this if. So it is this. Now wherever JDBC will come, it has to give one contains ABC or not, and it has to give one size also. And notice both operations are performing on collection reference variable, not on iterator. Run it. It is fine, no problem. Whenever JDBC is there, contains ABC false, size 10. JDBC is there, contains ABC false, size 10. JDBC is there, contains ABC false, size 10. Contains ABC false, size 10. Means what? Some method is working, not giving any exception, but some method is giving exception. when you can simply remember it in this way, when any iterator reference variable is pointing to any object, and at that time, if you apply as next, and remove. So these three functions, if you apply on iterate, from iterate time, if you apply some method which is from the collection interface, some method is giving exception, concurrent modification exception. Some method is not giving exception. For example, this two is giving concurrent modification exception, but these two method not giving any exception. Why it is so, or how will you remember? It is when any iterator is pointing to any collection object, and if you provide or if you perform any modification operation on this, any modification operation on this updatable operation on the collection object from the collection reference variable, then you get concurrent modification exception at runtime. Clear with this, everybody? An iterator is pointing to an object.
Sir, please repeat, sir, again.
Yes. One iterator is pointing to one collection object. At the same time, when iterator is pointing to a collection object, at the same time, if you perform any updatable operation from the collection reference variable, if you perform any updatable operation from the collection reference variable, updatable operation in the sense adding an element, removing an element, editing an element, this type of updatable operation. And that operation you are performing collection interface. At that time, iterator is pointing to this. Then you get a concurrent modification exception at runtime. Why this is so? Why it is so? So what we have said, again I'll write it here. Say I have, this is the collection reference variable, which is pointing to this object. It has some element, hi, hello, 99, something like this. And I have created one iterator also, which should point to this. This is the iterator. And it is pointing to before to the first element here. Then with the iterator, if I apply has next, and remove. No problem, fine. All the operation is going to perform on this collection. But in this time, instead of applying these three methods, this is already ready done. Iterator is created done, which is pointing to this place. Okay. And then here I am saying size. No problem, because it is not modifying the collection. It is not updating any element in the collection. If I say contains, it will give a true or false, not updatable operation in this. So no problem, fine. But if I apply add, it is an updatable operation here. It should add an element in this collection. Then, so suppose if I say here add, and it is adding the element at this point here, say something ABC I am adding. ABC. This is the newly added element. Then it is modifiable operation. It is updatable operation. Then you will get at this point concurrent modification exception at runtime, right? Or if I remove, then remove something, say remove 99. This is going to be removed. This also gives a concurrent modification exception, runtime. Why it is so? Why it gives concurrent modification exception? Because when you create an iterator, how long the iterator has to run? We don't know. Because of that, we have used while loop. Why we are not using for loop in this case? Why we are using while loop? Because we don't know the size of this before. Why we are using while loop? Why not for loop? Because we don't know how long the iteration has to run. Currently, we don't know how long the iteration has to run. And I believe you guys are very much clear with this, why, when you should go for loop and when you should go for while loop, right? So because I don't know how long the iteration has to continue, so I am using while loop. And because of that, I am writing here while it has next. Because limit we don't know. right? So I'm using while loop. Now, when you will create this iterator, internally, this iterator puts a boundary like this. It puts a boundary internally. And this gets the total count. How many elements are available in this? 1, 2, 3, 4. So currently it will get a count 4. Means next method has to run 4 times. At the time of creating this iterator object, when you will say here iterator, collection1.iterator, at that time only, this reference variable creates a boundary here and it says, okay, this many elements is available and this many times only next method can be used. Means this many times the cursor can move. This many times cursor can move. This many times cursor can move. That happens at the time of creating this iterator. Okay. So when the iterator is created, and if I add an element in middle somewhere here, or if I remove a particular element, then this iterator counts gets changed. Iterator counts gets changed. Because of this reason, it is designed in this way. If any iterator is currently pointing to this object, and if you apply add or remove function from the collection interface, then it should not work and it should give a concurrent modification exception. Right? If any iterator is pointing to any collection, it creates a boundary like this, it gets a count, how many times the next method has to work. And in middle, after creating this, if you modify this collection with adding an element, removing element, something like this, then that count mismatch. Because of this reason, whenever you will apply any add method or remove method, means any updatable operation when you will apply from the collection interface, say in collection interface I have add method with some object, then first it will verify if any iterator is pointing to this. If iterator is pointing, then throw new concurrent modification exception like this whenever we will perform. And because of this reason, this is concurrent modification exception, which is very, very important. Okay, concurrent modification exception, right? So this is concurrent modification exception. And when it comes, but assume I have a requirement like this, that I want, when an iterator is pointing to a collection object, still I want to modify that. Then what will you do? What is your idea? I have one collection reference, any collection, okay? One collection reference variable, which is pointing to this collection object. It has some element in this, hi, hello, JDBC, JSP, something like this. And then you are saying collection.iterator. Iterator is equal to collection.iterator. Collection.iterator, right? Means what? This iterator is pointing to before to the first element, right? Then on this iterator you can apply next, has next, and remove, right? All three methods you can apply, no problem. But when iterator is created, at that time, iterator has put a boundary on this. And it got the count, how many elements is available? 4 elements. Means from this count, iterator comes to know how many times you can say next. Means how many times you can move the cursor from one element to another element. How many times you can move? 4 times. After 4, if you again say next, then it has to give an exception. No such element exception, something like this, right? So it should give that exception. And when this count is created, at the time of creating the iteration. So iterator is created, it got the count 5, and after that if I remove one element, then what will happen? From the collection, one element is removed, and because of that this count should become 3. It will not become 3 because iterator is already created. So what you are doing, removing means what? It is updatable operation. After creating the iterator, if you do any updatable operation in this collection, then you get concurrent modification exception. Okay. Why it is so? Because this count increases or decreases with the iterator. You are modifying the collection, but it is impacting the iterator, which is not allowed. Before creating this iterator, before creating the iterator, any number of elements you add, remove, do whatever you want. Now, after creating the iterator, you cannot change the count. You cannot change the count. Why you cannot change the count? Because it got the number here. If you try to change the count, how will you change the count? Adding an element, removing an element, like this type of operation, updatable, which will update the collection. This type of operation, if you perform from the collection, then this gives concurrent modification exception. But importantly, remove. Notice here if I perform remove, this will not give concurrent modification exception. Why? Because it is with the iterator. It is with the iterator. With this count only you are doing remove. So this immediately gets updated 3. But from here, if I say remove, then get concurrent modification exception. Right. So this is when you will get concurrent modification exception. Now the question is, my requirement is I want a collection where iterator is created. I want to update, and I don't want concurrent modification exception. I don't want like this. Now this is the question. Instead of using here, what we did, we have said array list. Okay, you can say copy on write array list. What will happen in copy on write array list is, when you create array list, it is normal.
Sir, I'm having one question.
Yes, tell me.
So instead of that collection, give array list, sir, in this left side, sir.
This one you are telling? This one? You cannot give collection. Collection is an interface, right? It is dynamic dispatch.
No. Here you give array list, sir. In array list, we are having one method called as set. So set is also updatable operation. So if we perform that, again we'll get error or what I wanted to know.
Exactly.
Actually, if you are doing any updatable operation, then only we are getting error, no, sir.
Exactly.
Set is also updating some kind of operation. So will it give error or what I wanted to know?
It will give error. It will give error. It will give error. Okay. Any updatable operation you cannot do. So you have to use here copy on write array list. This one. Okay, you have to use here this one. Now this should not give any error. And how it works in this case? Do you have any updatable? Yes. Now I will add JDBC. Okay. Now run it. It is fine. No error. Right? Why no error? So this is also very, very important. Okay. You need to understand copy on write array list. And now how it works? Why copy on write array list is not giving any concurrent modification exception? Why array list is giving concurrent modification exception? Because when you create copy on write array list, this is exactly similar like this. Say you have a collection reference variable which points to this collection object. It has some hi, hello, JDBC. It has JSP. Okay, these are the elements. But it is not normal collection. It is copy on write. So what will happen is, when you will create an iterator on this, it will not point to this object. Okay, it will not point here. What it will do for iterator, it creates a complete new collection. It has hi, hello, it has JDBC, it has JSP. Okay. Now this iterator points before to the first element of this object, newly created collection object. Now the count is from here, not in this. Now if you do here collection.add, it is not going to impact in this. Okay. This remains as it is. Or if you add an element, say I'm adding here 99, I'm adding 88, I'm reviewing high, all these things I'm doing. This is not going to impact in this. So after creating this iterator, if I add some element in the collection, and if I use this operation, now here if I write while has next, all these things, this new is copy on write. Copy on write means when you create the iterator, it creates a copy. Of existing collection. Okay, this is why it is called as copy on write array list. And for this, I have written a blog on Facebook page, I think. Okay, the same thing, what we discussed here, the same thing is written there theoretically. Program also given for all this operation. You can go through there, you can copy the program, paste and check how it is working. Okay, so this is copy on write array list and concurrent modification exception, which is very, very important. You will definitely get interview question on this. Okay, so this is copy on write array list created. And from this collection, when you will create an iterator, it creates a copy of this collection here, creates a copy of this collection. And the iteration operation is going to perform on this copy, not on the original object. And because of this, if you add any other element in this, or if you remove some element from the actual collection, it is not going to impact into this copy. So iterator works as it is. Next, whatever modification you are doing at this place, those are not going to reflect in this iterator. This iterator remains as it is. Okay. So this is why here it is not giving concurrent modification exception, but here it is giving concurrent modification exception, because in this collection and iterator, both is pointing to the same object. And in this collection is pointing to one object. When you create iterator, it points to a copy object, not same. You can say it is clone. It clones the object and there it performs the operation with the iterator. Okay, it is clone. Here cloning is applied. First it will clone the object. On the cloned object, the iterator performs the operation. So in this collection interface you have seen, iterator method you have seen, these three methods you have seen, right? Next is come to this list first, right? List is an interface again, and it has abstract list, it has array list, it has linked list, vector and stack we have seen before, and now again we are not going to see. Okay, vector and stack we are not going to see. We're going to see array list and linked list as a concrete class. Okay, array list and linked list as a concrete class. Now first we'll see the list interface. List interface. And the collection methods we have seen here, like add with an object, contains with an object, and contains all, add all, remove all, retain, size, empty, is empty, all this inherited to list. On top of that, list has some other functions, like now if I create now the interface, this will take as a list only. Okay, this will take as a list only, but this will not take of type collection. This will take as type list. Okay, this is as type list. So I'll take one more test. So now we need to apply the methods of collection list interface. So this is of list type from util. And list is equal to new array list. This you can understand, right? By looking at this diagram, you can understand why it is array list. Because array list is a subtype of list and collection and all, right? So array list object you can store into list and you can store into collection also. Right, now add some object in this. Now the methods of this, right? Now till this how it is. This is the array list. List reference variable list, which is pointing to array list. This is array list. Array list type object. And whatever functions we have seen previously, like add, which is from the collection interface, that can be applied in this, because all that are inherited, right? So you can say here list.add with the function ABC. It is okay, right? This function is now not from list. This add function is not from list. Add function is from collection interface, okay, which is inherited and implemented in array list. Inherited and implemented in array list. So what it will do? It will add one object in the collection here. This is ABC is added, right? But my intention is not to see these methods. The method which is from the list interface. The methods which is from the list interface, those we have to see here. And in collection, assume in this collection I have some objects, something like this, list.add with some 99, list.add with something like this, right? So three objects stored in this collection. It has 99, 23, something like this. Now my requirement is I want to add an object at the beginning. Here. I want to add hi at the beginning. If I just write here add, which is the method which is from the collection interface, then this automatically adds the elements at last. Here it will add. I don't want to add it here. I want to add at this place, beginning. At the first index, I want to add an element. So that method is not available in collection interface. So that method is given in list. Like this, some operation which we cannot perform by using the method of collection interface, those methods are given in list interface. Those methods are given in list interface. For example, here it is collection interface, and it has a list interface, collection interface. In collection interface, you have seen add method with an object. In list interface also you have an add method, but it has two parameters. One is integer type, which is index, and another is object, which is element. Which element you want to store and where you want to store. This is which element you want to store, where you cannot tell. It will automatically go to the last. Okay. So now if I want to add an element at the beginning, here I cannot use the add function of the collection interface. I need to use add function from the list interface, and that is list.add. Index should be 0 and element should be hello. This. And after that you print the collection. And check list. Run it. It is fine. Hello is added at first. But if I before this hello, if I print this once, list, right? Before ABC is first. Now we have added hello at the 0th index. So 0th index is coming first. Okay. So this is the some functions, new functions implementation is given in list interface, which you can apply depending on your operation. So one from this is add, which is having two arguments. Okay, add. Next. Okay, we'll go in order. Add function we have seen first. Next, here we have seen the size function. Size. Empty, no argument in this. So this simply gives the size, and the same size function you can apply here also. It is inherited. So in this you can apply size. It is fine, no problem. Then we have seen is empty. So this is empty also. It is same here. You can apply, which is inherited one is empty. Contains function of a particular object. This is object argument. Contains function of a particular object, and it is fine. Contains is okay. So same contains in this collection also you can apply in this list. It is not having any new function in this contains. Then we have seen iterator. Iterator we have seen here. Same iterator also you can apply here, which is inherited one. Same iterator, no new version of this. Then we have seen toArray in this. toArray same you can apply here, no problem. Same toArray. New implementation is not given for this. Next we have seen remove with object. Which object you want to remove? It is from collection, okay? Which object you want to remove? That remove we have seen. How it will remove? This remove function, how it will work, we have discussed. First occurrence of matching element. Remove function from the collection interface works first element of matching, first occurrence of matching element. For example, it has again 99 here also, then it has high, then again it has 99. Now if I say remove 99, say I'm applying it like this on this list dot remove of 99. Which one will be removed? First occurrence of matching element. 99 is matching at this place. So this is going to be removed. But remaining remains as this 99, this 99 remains as it is. I don't want to remove like this. I want the last occurrence. In string class, we have seen last index of. But here, no such concept. Last remove, such kind of functions are not there. So in the list interface, you have a new method here, remove of int, which is index, Okay, index means in a particular index you can remove, not with matching with the object. In this object, to find out the matching object, it applies equals method. But in this remove, it will not compare the equals method or anything. Directly it will find out where is the index, this index. Okay, it will remove directly, no problem.